Hello, so today we are going to be finishing up the Unit 4 packet. So we're going to start on page 34. Okay, number 12 says, consider the polynomial function p of x. What are the solutions to this equation right here? All right, so we're going to solve this. So I'm going to just factor, make a t-chart, and solve. Now, I want to point out, please don't get fooled. Don't try to use the quadratic formula here, because in order to use the quadratic formula, remember your biggest exponent has to be a 2, right? It's called a quadratic. It has to be a second degree equation. This is not. All right, well, since the leading coefficient is 1, we are going to set up 2 sets of parentheses, and we are going to use the AM method. Now, since this is an x squared, an x to the 4th, we need to put an x squared in the first spot in each parenthesis. And then two numbers that multiply to negative 4 and add to negative 3 would be negative 4 and positive 1. And do not forget to bring down the equal 0, right? If this is an equation, we need to keep it an equation every step of the way. All right, now, although you could factor this one further to x plus 2 times x minus 2, this does not factor further, right? This is not dots. So you know what I'm going to do? I'm actually just going to jump right into my t-chart. If you would like to factor this one further, go for it, okay? X plus 2, x minus 2. So your solutions will be positive and negative 2. But I'm actually going to solve both of these the same way. I'm going to take each factor and set it equal to 0. And that way we just go about solving them both the same way. All right, so if I start with this one on this side, I would add 4 to both sides of the equation. If you want to show that, you can. You do not have to write plus 4 and plus 4. Okay, you could kind of just jump right to this. X squared equals 4. And then to get rid of a square, we take the square root. So that leaves us with x equals, now remember, this square tells us we have two answers. So this is not just going to be 2, it's going to be positive and negative 2. Okay, so we have two answers over here. All right, now on this side, we're going to subtract 1 from both sides of the equation, leaving us with x squared equals negative 1. And when we take the square root, it leaves us with x equals, now remember again, the square tells us we have two answers, so plus and minus. And the square root of negative 1 is just I. So here, I want to point out, we wind up with two imaginary solutions. Let's write that, two imaginary solutions. Okay, positive I and negative I. Whereas over here, we wound up with two real solutions. Sorry, that says real. So altogether, we wound up with 4 solutions, right? Which we kind of thought we might because this was a 4th degree equation. So we wound up with 2 real solutions and 2 imaginary solutions. Okay, so the next part says to sketch a graph of the same equation, right, this right here, as, look at this, what we had above. See that? See how these match up? All right, so let's do it. Now, I'm going to go to y equals in my calculator, and I'm going to use my calculator to help me graph this. Okay, so here we go. I went to y equals, and I plug this in. And I think my window may be kind of funky, so I'm going to change it to a normal window. I'm going to hit, instead of hitting graph, I'm going to hit zoom, and then the number 6. And let's just make sure I'm on a standard window. And when it says sketch, you don't have to include every point, but you want to include your important points. So basically, your x-intercepts, your y-intercepts, and the shape of the graph. So I can see that I have an x-intercept at negative 2, 0. I have another one at 2, 0. It looks like here my y-intercept is at, let's see, negative 1, 2, 3, 4, 0, negative 4. And, you know, if I want to just be sure, I can always go to second graph. I could look at the table of values, and it looks like here I'm going to include basically negative 2, 0, negative 1, negative 6, 0, negative 4, 1, negative 6, and 2, 0. Okay, I'm just going to include those 5 points. Okay, so again, I'm not going to include, I mean, really, I really need to include my x-intercepts, my y-intercept, right? And then I might as well include these 2 points as well, because it's going to help to give me the shape of my graph. Okay, so -2, 0, -1, -6, 0, -4, 1, -6, and then 2, 0. And we saw that the graph looked, right, something like that. So there's our graph. Y equals x to the 4th minus 3x squared minus 4. Okay, so it says, how many x-intercepts does the graph of the equation have? So we could see right here, we have an x-intercept here and another one right here. So we have 2 x-intercepts. Okay, then it wants to know what are the coordinates of the x-intercepts. All right, well, our coordinates are -2, 0 and 2, 0. All right, and then I just want to make a quick little note. So I'd like you to just kind of notice that up here, right, I'm going to slide this up a little. Okay, we had 4 solutions. We had 2 real solutions and 2 imaginary solutions. Now look at our real solutions, +2 and -2. +2 and -2. Don't those real solutions correspond with our x-intercepts? Where the imaginary solutions, although they are solutions to the equations, they do not correspond with any sort of x-intercept. Okay, so something I want you to make a note of is the imaginary solutions do not correspond with the x-intercepts, okay? Only the real solutions do. And that's going to help us with part C. So let's take a look at that. Okay, so are the solutions from part A, remember we got positive and -2 and positive and -I, right, in part A, the same as the x-intercepts from part B. Now remember the x-intercepts, we only wound up with positive and -2. So are they the same? And when it says justify, right, I mean your work above does justify, but we'll give a little bit of an explanation. Okay, so only the real solutions, right, the positive and -2 are the same. And make a note of this, okay? Let's write all this down. The real solutions tell us where the x-intercepts occur. Imaginary solutions do not. So basically, the number of real solutions within your equation is going to be equal to the number of x-intercepts. All right, so take a minute, hit pause if you have to, and copy this down, and then we'll go on to the next one. Okay, number 13. So now they give us a polynomial function, again, p of x, and they want to know what are the solutions. Now this time we can't factor, right? There are no 2 numbers that multiply to 7 and add to -2. This time, though, we can use the quadratic formula. Look, we have a quadratic. Our biggest exponent is a 2. So let's use the quadratic formula. All right, so here's our formula. In this equation, we have a being 1, b being -2, and c being 7. All right, so let's plug in the numbers. So x equals -2 would be +2 plus and minus the square root of b squared, so -2 in parentheses squared, minus 4 times a, which is 1, times c, which is 7, all over 2 times a, so 2 times 1. All right, so x equals 2 plus and minus the square root of that, let's see, 4 minus 28 would be -24 over 2. All right, I'm going to break up the negative radical 24 off to the side here. All right, so 24 breaks down into radical 4, radical 6, and then we have that -1. Now we know the square root of 4 is 2. The square root of -1 is I, and I'm going to bring down the radical 6. All right, so now we have x equals 2 plus and minus, and I'm going to take this 2i radical 6 and replace it for the negative radical 24. And we know that whole thing is over 2. All right, so now if we look at our numbers here, look, we have a 2, a 2, and a 2. Let's divide all those by 2, and let's just make them 1. So we'll have 1 plus or minus 1i radical 6 over 1. Okay, so x equals 1 plus or minus. Now, we don't have to write 1i. We could just write I radical 6. And we don't even have to put this over 1, right? Just, you can leave it as is because anything over 1 is itself. So these are our solutions, right? We have a second degree equation, and we wind up with two solutions. The first solution is 1 plus I radical 6, and the second one is 1 minus I radical 6. Okay, so those are our two solutions. Now, if you notice, look at this. Both solutions have an I in them, right? These are called complex solutions because we have an imaginary component. So here, we don't have any real solutions, right? So no real solutions. We have two complex solutions. So when we get down to our graph right here, sketch a graph. How many x-intercepts does the graph of the equation have? Well, remember, if there are no real solutions, there should not be any there should not be any x-intercepts. So let's graph this and let's take a look and see. All right, so I went to y equals and I plugged it in and let's hit graph. And look at that, there are no x-intercepts. Okay, so we're gonna, I guess, sketch this. Let me just go to my table of values. And I can see right here that the y-intercept, right, is at 0, 7. So I'm just going to make sure I go through the point 0, 7 and sketch something that looks like that. All right, so it's going to go through the point 0, 7, and it doesn't have to be great. It's going to look something like that. So there's our equation. And when they say how many x-intercepts does the equation have and explain why, exactly as we said, there's no x-intercepts because there are no real solutions. Okay, so there we have it. There are 0 x-intercepts. Since there are no real solutions, there are no x-intercepts. And there we have it. Okay, so now we're on the next page, page 36. And take a look at number 14. Okay, hit pause, see what you think, and then unpause and see how you did. All right, well, we could see here, right, that we have two real solutions, the -5 and the +3. So that means we're going to have two x-intercepts. We have two imaginary solutions, so those are not going to lead to x-intercepts. So if we look through, look at letter A. There's 1, 2, 3, 4 x-intercepts, right? Can't be that one. All right, let's also take a look at letter D. There's 1, 2, 3, 4 x-intercepts, so it cannot be that one. Okay, now that being said, let's look at our real solutions. Our real solutions occur at -5 and +3. So that means the graph has to intersect the x-axis at -5 and +3, just like letter B does. Okay, on accident, letter C switched the signs here. So that one is not going to be our answer. Okay, take a look at number 15, hit pause, and see what you think. And then when you're done, you can unpause and see how you did. Okay, so for number 15, they give us the equation, right, for this function p of x. So I graphed it in my calculator, and it looks something like this. So we were able to see here that we have 1, 2, 3 real roots. I'm going to write that down, 3 real roots, right? If it intersects the x-axis in 3 places, there are 3 real roots or 3 real solutions. Now here they gave us a picture of the function y equals m of x. Okay, here it is. And we could see m of x has 1, 2 x-intercepts. So that means this has 2 real roots. All right, so if you look at the answer choices, it looks like number 1 says that, right? It says that p of x has 3 real roots and m of x has 2 real roots. So there's our answer. Okay, so number 16. So read this, hit pause, see what you think, and when you have decided, you can unpause and see how you did. All right, so which representation of a quadratic has imaginary roots? So we know a quadratic is just a parabola, right? Like, so for example, what you see here in number 3. Now, a quadratic can either have, let me draw this out, 2 real roots, right? If it intersects the x-axis in 2 spots, it could have one real root if it intersects the x-axis in one spot. Oop, that's supposed to be touching right there. Or it could have no real roots if it does not intersect the x-axis at all. Now, if it has imaginary roots, that means we're looking for this. It's not going to intersect the x-axis. Okay, this is one real root, two real roots, and this would be two imaginary roots. So we're looking for a graph that does not intersect the x-axis. Okay, so for choice one, what I did was I just plotted these points. I went to negative 2.52, then I went to negative 2, 0, went to negative 1.5, negative 1, and so on. And what we could see is this right here would graph to be a parabola with two real roots. Okay, we're not looking for that. We're looking for imaginary roots. Okay, so choice one is out. All right, choice three. We could see this one has one real root. We don't want any real roots if it's a quadratic. We want imaginary roots. So it's not going to intersect the x-axis. So this one's out as well. Now, if we take a look at these equations down here, if we solve them, right, if we have an I in our answer, they would have imaginary roots. If they don't, then we won't. Okay, so I'm going to solve each of these. So if I solve number 2, I would first divide both sides of the equation by 2, leaving me with x plus 3 equals 32. Oops, sorry, I forgot about this little square. That square is kind of important, huh? Because now to get rid of that, I would take the square root, leaving me with x plus 3 equals, and that plus and minus tells us we have two answers, positive and negative. And then radical 32, I'm going to break that down into, I'll do it off to the side here. Radical 32 would break down into radical 16, radical 2. So it would be 4 radical 2. But now I want to get the x by itself. So if I subtract 3 from both sides of the equation, it leaves me with x equals. Now I'm going to order this. I'm going to put my negative 3 first, then my plus and minus 4 radical 2. Okay, so this has two solutions, but there's not an I anywhere, so they are not imaginary. So I'm thinking choice 4 is the answer, but let's just solve and make sure. Okay, so to solve this, I mean, you could start these a couple different ways. I guess I'm going to just subtract 32 from both sides of the equation, leaving me with 2x squared equals negative 32. And then I'll divide by 2 to get that x squared by itself. Leave me with x squared equals negative 16. And look at this. When we take the square root, that leaves us with x equals plus and minus. Now remember, if you have a negative under the radical, we're going to have an I in our answer. So the square root of 16 is 4, and the square root of negative is I. So this is going to be plus and minus 4i. So this is the one with the imaginary solutions. Choice 4 is our answer. Okay, and then finally number 17, factor completely over the set of integers. All right, well, if we were to factor this, I mean, we can't pull out a greatest common factor, but this right here is dots. It's a difference of perfect squares. So I'll set up my two sets of parentheses. We know with dots we have 1 plus and 1 minus. And we're going to put the square root of the first term in the first spot in each parentheses. So the square root of 16x to the 4th would be 4x squared. And then we're going to put the square root of the second term in the second spot in each parentheses. So the square root of 81 is 9. Now, this word right here, factor completely. That word completely is very important. It's letting us know that we have to look to factor further. So if you look in the second parenthesis that we have, isn't this another difference of perfect squares? Okay, the first one's not because of the plus sign. So we're going to just bring down that 4x squared plus 9. But let's split that second parenthesis up into its two vectors. Okay, again, one gets plus, one gets minus, and the square root of 4x squared is 2x. And the square root of 9 is 3. And if we look here, nothing can be factored further, so that's it. Okay, so part B says, Sarah graphed the polynomial. So she basically graphed this. She went to y equals and graphed this and stated all the roots are real. Is Sarah correct? Explain. All right, I'm going to take a look at this a couple different ways, but if we know that these are our factors, we could just set this equal to 0 and solve. So let me do that. Okay, so here we go. Let me just give myself a little more room here. So basically it's already in factored form for us, so we could just make a t-chart and solve. All right, so I'm going to first just set this first factor equal to 0, and I'll solve. So if I subtract 9 from both sides of the equation, that'll give me 4x squared equals negative 9, and I guess I'll divide by 4, leaving me with x squared equals, I'm going to leave it as a fraction, negative 9/4. And when I take the square root, right, we know we're going to have plus and minus because of this x squared. And the square root of 9/4, so square root of 9 is 3, and the square root of 4 is 2. So it'll be 3 over 2. But don't forget about that negative under the radical. Doesn't that create an I? Right? So we have 2 imaginary solutions. Now, technically, you could solve these further, right? And I'm going to jump to the shortcut. Do you remember that to solve for, since there's no square on here, x would be equal to the negative of this number over that number. So we're going to wind up with x equals negative 3 over 2. And over here, right, if we set this equal to 0 and solve, the shortcut would be we're going to wind up with the positive of this number over the number in front of the x. So over here we'll wind up with x equals positive 3/2. So these two solutions are real solutions because there's no I attached to them, whereas these two solutions are imaginary solutions because of the I. So I could say Sarah is incorrect, right? Sarah had said that all of the roots are real. Sarah is incorrect. There are 2 real roots, right? Plus and minus 3/2, and 2 imaginary roots, plus and minus 3/2 I. I do want to point out that you could have done this graphically. You could have went to y equals, plugged in the equation, and when you hit graph, what you'll notice is here, there's only 2 real roots, right? There's one right there. I guess that would be at what, negative 3/2, and one right there at positive 3/2. So you would have to draw, if you want to do this graphically, you'd have to draw a picture of this graph, and then technically there, because this is a 4th degree equation, we could have up to 4 roots. But because we're only seeing 2 x-intercepts, what that tells us is that 2 of our roots are real and the other 2 roots are imaginary. Okay, so you'd have to explain that in words. Okay, so you could have drawn a little sketch of the graph and said Sarah is incorrect. Since the graph has only 2 x-intercepts, there are only 2 real roots, meaning the other 2 are imaginary. Okay, because if we have a 4th degree equation, we would have 4 roots altogether.